So here we need to show that sine theta plus I times cosine of theta whole raised to the power of n is given by this particular expression. So let's first begin by stating the de Moivre's theorem, which states that whenever we have cosine of theta plus iota times sine theta raised to the power of some number n, then this becomes equals to cosine of n theta plus iota times sine of n theta. Right. Now, whenever we apply de Moivre's theorem, we have to make sure that the real part is a cosine function and the imaginary part is the sine function. But if we start from the right hand side, on the right hand side we have a sine function on the real part and the imaginary part consists of the cosine function. So that means we'll have to change the sine to cosine. That means the real part to a cosine function and the imaginary part to a sine function. To do that, all we have to do is use the fact that sine theta, which is the real part, that can be also written as cosine of pi over 2 minus theta. So in the first quadrant, the trigonometric functions are positive. Similarly, cosine of theta, this will be equals to sine of pi over 2 minus theta. That means our expression, if we start from the left hand side, our expression can be rewritten as, in place of sine theta, we will have cosine of pi over 2 minus theta plus iota times sine of pi over 2 minus theta whole raised to the power of n. So we convert sine theta, which is the real part, to a cosine function, and cosine theta, which is the imaginary part, to a sine function. Now we can successfully apply the de Moivre's theorem. That means we will have cosine of n times pi over 2 minus theta plus iota times sine of n multiplied to pi over 2 minus theta. So this will give us cosine of n pi over 2 minus n theta plus iota times sine of n pi over 2 minus n theta. This is equals to right hand side. So except we have successfully shown that sine theta plus I times cosine of theta whole raised to the power of n is given by cosine of n pi over 2 minus n theta plus iota times sine of n pi over 2 minus n theta.